Yeah, I'm just kind of leaving Brian Kern's notes as they are. Okay, so I just went over the possibilities for projects. At this point, I just want to do a little bit of review here. So week 5, ethanol debate. Let's see what's new. What's new? All right, Jason. I have that the energy return on energy invested is not near that of petroleum. Now, that is that's true to some extent, and the interesting thing to note on that is eventually it will be. As petroleum is harder to find, and here's something that just fascinates me, and this is what led me to start a company called Human Powered Future, because if you sort of go back to pre-humans and pre-technology, that's really all that's all we had, before we tamed horses, and I think that's really where our society is going. I mean, there are these net zero homes popping up where you've got your solar, you've got your solar thermal, you've got your geothermal. You really don't need much beyond that. There's almost no need to set natural gas on fire for at least for space heating. Maybe for cooking. Maybe not, depending on whether or not you can have a nice hot source or use a solar oven or what. But I think we're going to get to a point where, yeah, it's just, sorry, but no more setting things on fire to make heat. It's just going to happen. It will eventually. And so, yeah, what you're saying here is true in most cases, Jason, but there are petroleum wells that where the EROEI is terrible, meaning that you can just keep drilling and you're not going to get any more petroleum simply because there's not down there. But yeah, in general, for let's just say U.S. domestic ethanol from corn production versus Middle Eastern oil production, yeah, Middle Eastern oil production is going to win the EROEI contest.
You better address that second statement too, because methanol, if we went to total methanol, wood alcohol, it would totally kill the atmosphere. It would totally kill pretty much people too. Because the methanol poisoning, you can actually get it from inhaling the exhausts.
Where are you seeing methanol?
Well, the fact that we can use wood waste products should be a primary use to make ethanol. You can't make ethanol with wood products. You gotta make methanol.
Yeah, wood to ethanol is a little more difficult. And what's your argument against methanol burning?
Is that it's not conducive to where we're trying to go with the environment. Because, it's not going to put many greenhouse gases in the environment that's not going to already be there, but it's going to put a gas into the atmosphere that's toxic for humans to breathe.
Remind me what the methanol combustion looks like.
What it looks like?
Well, they all go boom. I'm just trying to remember the equation there. Okay, so you've got 2Ca. So I guess here's the methanol combustion. I mean, if it goes to completion, it's just CO2 and water. So I'm just wondering what the concern is there.
That was one of my big things, because I was doing that too. I was in the methanol chapter.
Okay. So I think almost all of these hydrocarbons, if burned to completion, really your only two combustion gases are carbon dioxide and water. Yeah, we were just doing this, the other day, so if we look at,
Yeah, because I come to the conclusion when I was reading through this, that it'd be more productive for everybody if we just took the methanol and made dimethyl ether out of it.
you know, I was just digging on this paper yesterday. If we look, if you gasify wood, and we do have a really neat wood gasifier here, you can see that one of the main reasons that you've got so much oxygen, thus making the methanol. That's just what the composition of wood is. It's mostly carbon, and the remainder is hydrogen and oxygen, tiny bit of nitrogen. That's the ash-free. Of course, if you've got some bark that's been near, dust, you might have some silicon in there. You might have some iron. If you live near Libby, you might have the elements from asbestos. This is a good little paper. Volatile yield, approximate analysis. If somebody wants to actually do this ASTM test method, there it is, ASTM E870-82. That'd be a good one. Run that to make some wood gas. Okay, well, I think we're caught up there. Let's go back into the... I hopped out of the website here. Let me just get back. Okay.
Talking about an increased number of people could be exposed to environmental methanol as a result of the expanded.
Oh, well, yeah, you wouldn't want to breathe the methanol itself, right? Any more than you want to breathe vaporized octane, sure, yeah. Yeah.
That's where I was getting.
Okay. Yeah, unfortunately, like a lot of these things, it really does come down to pick your poison. There's no perfect technology.
Well, then, I guess if you had the methanol like that, you'd have pretty much a whole closed environment. Then it'd be like you were in Oregon, you couldn't pump your own methanol gas. And
there are farmers here in Montana starting to make their own renewable fuels. All right, Jason, lighten up the discussion board again. Okay, as stated in the International Biomass Business Times, Goodbye Oil, U.S. cracks new successfully flown a model aircraft on seawater fuel. After decades of research, they came up to develop extract carbon dioxide and hydrogen gas from seawater. Yeah, I want to check this out. I remember seeing something about this not too long ago. This also seems one of those, like one of those EROEI, oops, let's go here, problems. Yeah, I think this is something we might have looked at in 102. That doesn't seem like enough vessels to me. 300?
Here comes the king.
Yeah, but that's the 289 vessels, all rely on oil-based fuel. That's only the vessels that rely on oil-based fuel.
No, I just, well, it just it doesn't seem like enough vessels. I mean, maybe major vessels, I don't
The
know.
Navy, I mean, I talked to, he's the Navy's operational, he's the commander for operational fuel. No, that was Army operational fuel. I'm blanking on his name. Anyways, I talked to him, and they all told me, yeah, we floated an entire fleet on biofuel. Floated an entire fleet, I mean, the Blue Angels have flown biofuel. The Navy circumnavigated, high circumnavigation of the globe with jet plane running off biofuel. But I don't know if it was, skim that. I don't know either.
Yeah, these things, it's too bad all these sites usually come with some of this stuff. Yeah, I'd like to, so, this is the paper that I'd like to see, Will Hour. I might actually have a copy of Will Hour. Let me just see if I have that really quick. Okay, so I found the paper, and this came out relatively recently, 2013. There they are, Naval Research Lab. Heather Willauer is one of the scientists on it. So CO2 hydrogenation to oleins and ethylene oligomerization were investigated in reports to improve catalyst composition reaction needed for scale-up. The hydrogenation, so putting hydrogen into carbon dioxide, into a hydrocarbon, over alumina-supported iron-based catalyst modified with manganese and potassium promoters and a silica-stabilized coating under something bed reactor conditions to produce unsaturated hydrogen feedstock for jet fuel synthesis. The stabilizer is induced by impregnating potassium, manganese, iron on aluminum oxide catalyst with tetrathiosiliciates to minimize the decavitating effects of water on catalyst activity on CO2 hydrogenation. The catalyst modified with TOS and reduced in CO produced lighter end fraction oleins compared to the catalyst reduced in H2. To increase the chain length of the oleins formed in the CO2 hydrogenation step, investigation of the oligomerization, so this is just meaning making the molecule longer, not polymerization, but oligomerization, so medium-sized molecules, is conducted in a separate experiment where pure ethylene, we know what that is used as a model olein. Ethylene oligomerization over pelletized amorphous silica aluminum demonstrated high conversion towards the jet fuel. So that's more or less octane. There must be an O there. There's an OH in there, I'm not sure. A very low. The reason, these are just some kind of symbols. Well, that's obviously an arrow.
The boxes?
Yeah,
Oh, and it just,
the different box, just for whatever reason, the font wasn't picking up.
the acrobatics of picking it up.
Yeah. But, okay, so here's your CO2, and we know that there is CO2 in the ocean.
Yeah, it's one of the sinks.
It's absorbed. Now, I was not aware of the fact that there's hydrogen gas absorbed in the ocean, but there it is in black and white. So if you combine. Now, these aren't just, you aren't just like putting these in a chamber somewhere together. This all has to happen on a catalyst. So there's your there's your CO2s. Let's just look at this. So the N, let's just do the balance. So there's N carbons on this side, N carbons on this side. Now let's do the hydrogens. So there are 2 N hydrogens here, 2 N hydrogens there. That's fine. Now we've got N oxygens plus N oxygens is 2 N oxygens. So that's the first scale up. So you've ripped an oxygen. I think you were even asking me this question the other day, like how do you just get rid of CO2? Well, here it is. It's happening on top of these catalysts. So now you've got your CO2 and your H2O. This would come off, and it's not saying that this is happening in gas or liquid. I'm going to assume this is a gas and this is coming off as a liquid. So now you send your CO in with more hydrogen. You're sort of hydrogenating that CO. This is ethylene and water. Now you're going to take this CO2 again, so it's just like this first equation. Now you're just going to shove more hydrogen at it and make some kind of polyethylene. And you just keep bumping this up. You go from ethylene to butane to octane, which is right there. That's what they're looking at. Oh, you know what? I think, oh, I see. I bet this little symbol right here is just a tilde. I think this is probably what they're trying to say here. C8, C16. So what they're showing with these reactions is every time you do this, you double it. You double the length. 2, 4, 8, 16. And then, let's see, finally, or is this is maybe a separate reaction. Carbon dioxide plus hydrogen gives you methane and water. Okay. What's not clear is the energy return on energy invested. So the question is, how are you extracting the CO2 and the H2 out of the ocean? That's the question I have. Unique challenge and opportunity. These future technologies must minimize their impact on the environment, especially carbon dioxide, because CO2 is readily available. Because CO2 is readily available from the air, seawater, and as a byproduct of many industrial processes, coal-fired power plants, and the Fischer-Tropsch process, it serves an abundant chemical feedstock.
Fisher, Carl Fisher, it's titration.
Yeah. Additionally, processes that use waste CO2 from the environment could be envisioned as CO2 neutral. So carbon dioxide recycling is what they're talking about here. U.S. Naval Research Labs recently reported developing a process to recover, so we have to go and dig into this paper, from seawater. CO2 is 140 times more concentrated in seawater than in air on a weight per volume basis. That's a good number to know. I did not know that. Because this technology is currently being scaled and optimized, new and improved catalysts are being developed for the conversion of CO2 to energy rich by NRL and others. The current involves two-step synthetic process. There we go. Okay, in the first step, carbon dioxide and hydrogen are reacted over an iron-based catalyst.
Only offense, that box is an FI, you can see where the coal-fired FI is.
Oh, FI. Yeah, there we go. Acrobat always has trouble with the FI. The mechanism of CO2 hydrolysis has been proposed to occur in two steps. We just looked at those. The reversed water gas shift is there as well. Is endothermic and produces carbon monoxide. So it gets colder as it goes.
Exothermal titration.
CO is then carried forward in an exothermic, Fischer-Tropsch, producing predominantly mono unsaturated hydrocarbons. There's this guy. Carbon dioxide is also hydrogenated directly into methane in a widely cited thermodynamically favorable and highly competitive side reaction, equation 4. The water formed the primary reactions involved in CO2, negatively influence. Okay, so the water, it just says it's kind of messing with the production. The water formed is known to negatively influence catalyst activity and produce selectivity. One objective of this study is to modify the catalyst surface with a silica-stabilized coating to prevent the water vapor produced from negatively influencing it. Okay. By decreasing the effects of water vapor, equilibrium should favorably shift the production of This is kind of wild. This whole thing is going through a 3 angstrom sleeve. So
Really,
it's an atomic.
Smaller than a benzene ring,
Yeah,
because a benzene ring is 4.
yeah.
So
So there's-
I mean, it's just tiny.
So there's some pretty high tech, pretty high tech going on here with this. You don't just do this in your backyard. So here comes the CO.
So that's probably the sleeve that they need to change when titrated.
Yeah, well, I think I don't see exactly where the water is.
There's a liquid trap there.
Yeah, and I'm guessing that's just that's my guess. My guess is the water's down there in the bottom.
And are they pumping nitrogen into it too?
Yeah, I don't know what the nitrogen is doing there. It's not mentioned in the text.
No, but it goes to the bypass.
It might be. Let's see if we can find it here.
Ball valve.
Drying with nitrogen.
Oh, is that what it is? So it's basically freeze drying.
It's reduced. The reactor was purged with nitrogen for 1 hour prior to reducing the reactive gases. So the nitrogen is not reacting. It's just for thermal control.
So in other words, it will wrap that pipe and cool that pipe down right there.
That's what it sounds like.
Maybe that's the condenser. Well, it's kind of funny, I pull out my pocket computer, it's right on ASTM standards.
Nice.
Oh, yes, that's Central Standard. Couldn't take it no more.
Yeah, this would be a good paper to know. This would be a fantastic paper to know. I mean, this is, and we had this discussion a little bit today in Energy 101 about, once we've sort of pumped all of the economically recoverable oil, gas, ancient hydrocarbons out of the Earth's crust. You know, we still have this carbon kicking around, either in the atmosphere or in the ocean, bound to oxygen. At that point, it's just a matter of reversing it. Now, what I'm not seeing in this paper is the energy that goes in, sort of the energy required to drive it.
It's gonna be a lot more than what they're gonna get out.
Well, maybe, maybe not. I don't know. It's just not given. Because obviously you have to pressurize those tanks. There were some other papers discussing how the two gases are extracted from the ocean, but the other question is where, you know, where is that primary energy coming from? And ultimately, we'll need to get it from the true renewables, not these ancient sequestered chemicals. All right, that'll do it for today. Any other comments there, Gary? Good. All right. So start on your term paper, and I'm going to make sure that Tim catches up on all the grading. So I think that's going along pretty well. If you run into a snag, shoot me an email. Shoot me an email. Thanks.
That solar and wind paper